Hey, welcome back. Here we go. This is, I think it should be maybe not easier, but kind of coming together, hopefully. So, now we're going to talk a little bit about like terms and what we can combine and what we can't. So, we're going to simplify each expression. We have 3x plus 9 plus 2x minus 5. Well, we see that 2x and 3x are alike. Those are called like terms because they both have the same variable, which is x. And 9 and 5 are alike. They're both constants. They don't have a variable, so those are alike, aren't they? So we can rewrite this to help us wrap our minds around it by rearranging it so that they're next to each other. That's the commutative property of addition. But we have to make sure they stay in the same order. The 9 and the 5 have to stay in the same order because we have subtraction. So 3x plus 2x, well, how many x's is that? That's 5 x's. Yeah, they broke it down into 3 plus 2x, but I think that's a little redundant if you ask me. So you can see that 3 plus 2 is 5, so that's going to be 5x's, and 9 minus 5 is 4, so that's going to be 5x plus 4. So this is where we got to be careful when we start to get with these positive and negatives, plus and minus. Okay, so you see 3x plus 2x, that's 5x's, and 9 minus 5 is 4, and you can simplify it real quick if you do it that way. That's the way I like to do it. So we have y plus y plus y. Well, how many y's do we have? 3, right? So each of those have a 1, imaginary 1. We don't write the 1 because we can see that it's just one y. So we end up with 1 plus 1 plus 1, which is 3. But if you want, you can just say, oh, 1y plus 1y plus 1y is 3y. This is a lot of steps for something like that. You can, to help you, if it helps you see what each step is, that's great. But I think if you can see that this is just 3y's, you can write it like that. Now we have 7z plus 2z minus 5y. And now our order of operations says parentheses first, right? So I need to multiply 2 times z and 2 times 5y. So that's what this is. You have 7z plus 2 times z, which is right here, and then 2 times 5y, which is right here. So now I end up with 7z plus 2z minus 10y. Now notice these have the same variable. So those are called like terms. They are alike. So I can combine those. What's 7 plus 2? Well, we have 9. So 9z minus 10y would be our final answer on that one. So go ahead and pause the video. You can kind of see what they're doing there, using the distributive property and combining like terms. All right. Another example, a few more examples. So we're going to see that 7w minus 4 plus 3w plus 11. I can see that there's like terms here, 7 and 3. So you can see that how many w's? 7 and 3 makes 10, right? Now this is where it might get tricky. So you want to take a look at the video and see. Here we can see there's 4 b's, right?
Simplify each expression.
And let's just
Part
watch
A,
the video on how they
7w
do all
plus 11
those.
plus 3w minus 4. First, use the commutative property of addition to change the order of the second and third terms so that like terms are next to each other, obtaining 7w plus 3w plus 11 minus 4. Then use the distributive property to rewrite the expression as the quantity 7 plus 3 times w plus 11 minus 4. Then simplify the expression. 7 plus 3 is equal to 10, and 11 minus 4 is equal to 7. So in simplified form, the expression is equal to 10w plus 7. Part B, b plus b plus b plus b. First, use the multiplication property of 1 to rewrite the expression as 1b plus 1b plus 1b plus 1b. Then use the distributive property to rewrite the expression as the quantity 1 plus 1 plus 1 plus 1 times b. Then add the coefficients. 1 plus 1 plus 1 plus 1 is equal to 4. So in simplified form, the expression is equal to 4b. Part C, 2c plus 3 times the quantity f plus 5c. First, use the distributive property to rewrite the expression as 2c plus 3 times f plus 3 times 5c. Then multiply. 3 times f is equal to 3f. 3 times 5c is equal to 15c. So you have 2c plus 3f plus 15c. Then use the commutative property of addition to change the order of the second and third terms so that like terms are next to each other, obtaining 2c plus 15c plus 3f. Then use the distributive property to rewrite the expression as the quantity 2 plus 15 times c plus 3f. Finally, add the coefficients. 2 plus 15 is equal to 17, so in simplified form the expression is equal to 17c plus 3f.
So that last step there, where you break apart the 2 and the 15, I think that's a little redundant. So if you can see that 2c plus 15c makes 17c, I would just do that. And that's a lot of stuff. So if you need to pause the video, that guy went pretty fast. Why don't we try these two? We'll do them together here. So 8 plus 3z minus z. Well, I see these are like terms. 3z minus 1z, right? So that gives me how many z's? 2 z's. So I end up with 8 plus 2z because 3z minus 1z is 2z's. 1z. Get it? 1z? Anyway, here we have 3b plus 5, so I need to distribute the 3 into here. So 3 times b is 3b. 3 times 5 is 15. Then I have 3b plus b, which is 4b's, and then 15 plus 2, which is 17. So that ends up being 4b plus 17, and this one is 8 plus 2z. I know that's a lot, and we're going to work on it together in the Google Meets if you need to. So make sure we're meeting if we need to see some more examples. Pause the videos if you need to as well. I know that's a lot of stuff for this chapter, but you guys are doing